We all know that AIs are trained on just massive, massive amounts of data. But what if that's actually the wrong way to go about it? Today, we're going to dig into a really cool idea: how to teach an AI to learn smarter, not just harder. Think about it this way. You can make a student read, 1,000 books, and sure, they'll know a ton of facts. But how do you actually teach them to think, to solve problems they've never seen before? Well, that's the exact same challenge that's facing AI researchers right now. You see, the old way, what we could call brute force learning, is kind of like forcing that student to read an entire library from cover to cover. It's incredibly slow, it's super inefficient, and let's be honest, most of that information is redundant. But this new smart learning approach, it's totally different. It's all about finding those few key chapters that contain all the critical lessons. So to really appreciate this new, smarter way, we first have to get our heads around the fundamental problem with the old one. And it all boils down to this concept called signal dilution. The core problem here has a name: signal dilution. Imagine you're studying for a huge math test. Now, if 99% of your practice problems are just simple addition, but the actual test is on calculus, well, you're not really learning very effectively, are you? The truly important lessons, the calculus problems, are getting drowned out or diluted. For an AI, it's the same thing. Most of the data it sees is uninformative, and it slows its learning to an absolute crawl. Okay, so if most data is basically just noise, where's the actual signal? Where are the good lessons? Well, the breakthrough insight here is that the most valuable lessons, they're found in the extremes. Let's jump back to our student analogy for a second. Imagine our student takes two different practice tests. Which one of these do you think is actually the better learning opportunity? So on the left, you've got low contrast, where all the scores are bunched together. It's kind of an easy test. Every result is pretty predictable. But look at the right, high contrast. You've got this huge spread of results, some big wins, but also some really tough losses. And that contrast, that wide range, is what creates a powerful learning signal. It shows the AI exactly where it's strong and, more importantly, where it needs to get better. This spread is everything. Now, this slide gets right to the heart of the research. And I know, it might look a little technical, but the idea behind it is actually pretty simple. Maximizing advantage variance, that's just a fancy way of saying focus on those high contrast examples we just talked about. And higher policy gradients, that just means the AI takes bigger, more confident steps forward in its learning. So the crucial point is this: an AI learns fastest when it focuses on the examples with the most dramatic outcomes. The spectacular successes and the total failures. That's where the real lessons are hiding. Okay, so how do you actually put this into practice? Well, researchers developed this framework called D3S, which stands for Dynamic Dual-Level Downsampling. Yeah, it's a mouthful, I know, but just think of it as the ultimate personalized study plan for an AI. D3 works in two really smart steps. First, at what they call the sample level, it sifts through all the training data and pulls out only the batches with the highest variance, the ones with those really dramatic outcomes. Then it goes even deeper. At the token level, it pinpoints the most impactful moments within those already selected batches. So how does it know which moments are the important ones? Well, it uses this really clever formula. It looks at the advantage, which is basically how much impact a specific piece of data has on the final result. Then it multiplies that by entropy, which is just a technical term for the AI's level of uncertainty. The whole goal is to find those perfect learning moments, high-stakes situations where the AI has absolutely no idea what to do next. But a smart study plan has to be more than just a cram session, right? If our AI student only focuses on the hardest problems, they might just end up memorizing the answers without really understanding the concepts. And in the AI world, we have a name for that. It's called overfitting. So D3S avoids this with a dynamic schedule. Early on, it's super aggressive, focusing only on the top 5% of the most informative data to learn really fast. Then, in the middle phase, it starts to broaden its knowledge, bringing in more diverse signals. And finally, in the late stage, it relaxes the criteria even more, reviewing the top 20% of data just to make sure it has a robust, generalized understanding of everything. And this is the absolute key to true mastery. It prevents the AI from reward hacking, which is kind of like a student finding a loophole to pass a test without learning a single thing. Instead, this dynamic approach forces the AI to build a deep, flexible understanding that actually works on new problems it's never seen before. So the theory sounds fantastic, but does it actually work? Let's take a look at the results. And honestly, they're pretty impressive. Okay, let's look at how this performed on a really challenging math benchmark using the Qwen2.5 model. The standard training method, called GRPO, gets a certain score. But when you add the D3S study plan on top of it, boom, the score jumps significantly. It means the AI is just flat out getting more problems right on the very first try. But better performance is really only half the story. The other factor, which is maybe even more critical, is speed. D3S doesn't just make the AI smarter, it makes it learn at a stunningly faster rate. We're talking about a speed increase of over 5.5 times. What this incredible speedup means is that the model reaches its peak performance using far less time, far less energy, and far less computing power. It's a huge leap in efficiency, and it basically makes the whole process of training and updating these AI models much, much cheaper. And these improvements aren't a fluke, they're consistent across the board. On another difficult benchmark, you can see D3S boosts both the pass at 1 score, that's getting the answer right on the very first attempt, and the pass at 8 score, which allows for multiple tries. This shows the AI isn't just getting lucky, it's becoming a fundamentally better problem solver all around. So let's just recap the key takeaways here. D3S is this powerful new approach that seriously speeds up AI training while also boosting its performance. It does this by focusing on only the most informative data and using a smart, dynamic schedule to avoid bad habits. The end result is just a much more efficient, more effective way to build smarter, more capable AI. And that kind of leaves us with a pretty profound question to think about. This research offers a blueprint for making AI development faster, cheaper, and way more effective. So as we wrap up, just think about this. What happens when every AI can learn not just harder, but smarter?